Hi, good evening, everyone. Hi, good evening, everyone. So, I am Shubhanu. I am a PhD student at IIT Delhi. So, we'll be starting our today's session for this is week 10 for operating system fundamentals. So, today we will be focusing on the leftover part of the memory management, and also we will be seeing some concept of the virtual memory and all. So we'll be start very soon. Please also uh, let other also join. So we'll be starting very soon. Okay. Yes, I hope my screen is visible to everyone. So this is the first questions for today's lecture. So last week also we have solved questions on the logical address space and about the paging scheme and all. So, so this is the first question for today. So suppose in a three-level paging scheme, so there are three levels of paging. Okay. Now they are asking that the second outer page table is of size 16 MB, and the outermost page table is of size 4 MB, and the inner page table is of size 4 KB. Then assuming that each entry in the page table consists of 4 bytes, how many bits are required for the second outer page table and inner page table and page offset? So please try to solve the this question by yourself first. Then I'll definitely tell how to solve this. So, do you know why there is a need of multi-level paging? Okay, because it is difficult to store such a huge page table in the memory. Yes. No. Yes, that's fine. So that's why you need the you need the page table. But why there is a need of multi-level paging? So multi-level paging can solve this problem. Mm, okay, page table size is larger than the frame size. Okay. Mm, mm. So I hope that you are trying to solve this question. So 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 I will also I will also try to make you understand that what is happening here. Yeah. So we have something like so the physical address space is of 2 to the power 44 byte, and logical address space is of 2 to the power 32 byte. Okay. So I have page table 1 and page table 2. So like this is the structure. So we have like always we have some frames like this, frames or pages whatever you call it. Like here also. Right, this is 2 to the power 32 frames in the physical address space. And here we have how many pages in logical address? We have pages, right? Now if you have page size, PS mean page size, okay, page size is of 4 KB. This also means this is equivalent to size of frames. So page size means size of frames. So what is the size of frame? So size of frame means like this one, this one frame size, or this one frame size. So this is also 4 KB, this is also 4 KB, and this is also 4 KB, right? Fine. Okay, so now we know that to represent, like we can assume that to represent one frame we need 32 bit, right? Okay, now this page table has 2 to the power 10 entries. Okay, this page table also we assume that 2 to the power 20 entries. So this, for page table we call it entries. Okay, here we call it frames, here we call it pages, right? Now for each frame, so you would both of your answer is right, that because it is difficult to store. Why do we need page table 1 and page table 2? So because it is, the program is very big and it is difficult to store such a huge page table in the memory. Okay, now then what is the goal? That our goal is to represent each frame. We know that for representing each and every frame we need 32 bit number. Okay, so this page represent some pages here which is 32 bit. Okay, so in this page table 2 we say by address of page table 1. Okay, in page table 1 we say address of the logical space, right? So this is how we save it. Okay, now what is the page table size then? Page table size, PTS mean page table size. Page table size is equal to 2 to the power 10 into 4 KB, 4 byte, which is 4 KB, right? Now what is the page table size of page table 1? This is page table 2 is equal to 2 to the power 20, because 2 to the power 20 entry into and 4 byte simple, right? Okay, right? Then but this page size is equal to 4 KB. Okay, so how many number of pages you have? Number of pages is equal to 4 MB by 4 KB. This is equal to 1 kilobyte. This is the number of pages, right? Now here we have 2 to the power 44 by 2 to the power 13, that is equal to 2 to the power 2 to the power 12, that is equal to 2 to the power 32. So this is the number of bit required to identify. So you know that we have 2 to the power 44, right, and by 2 to the power 12, so we got 32 here. Okay, so this number represent that number of bits required to identify each pages, right? And here we have 2 to the power 32 by 2 to the power 12 byte, that is equal to 2 to the power 20. So this is the number of pages we get from this process. So we can start from here. Like, first we want to know that first we have a process, okay, or we have a program. So this is our program. So our program is of 2 to the power 32 byte. Okay, we have logical address space 2 to the power 32 byte. Then we from here we can understand what is the number of pages. From here we know that number of bit required to identify each frame. Now we have page size, page table size and all. Okay, so the page table will show in which location of main memory each page is present. Okay, so multiple page table is required to keep track of all the processes. The page table will show in which location of main memory each page is present. The entry of an page table point to a main memory frame, like this. The page table will show in which location of main memory. So this is the location of main memory. Which location of main memory each page is each page is present. To show the page number 4 is present in frame number 5 in main memory, page table never contain the page table number. So the page table entry should identify the frame number. So each page table entry should need 32 bit to identify each frame. Okay, so now page table 1 contains 2 to the power 20 entries, each of size 4 byte. Page table size is 4 MB, but each frame size is 4 KB. We have this page table size, which is we have found out that this is 4 MB, but each, so we need to store it here, right, in one frame. So we have found out that we can do that thing. So but each frame size is 4 KB. So this page table is so big that this can go and sit in one frame. So that's why we will divide this page table again and then make the page table 2. Got it? So this is the idea. Okay, now the thing is, yeah, so we to solve the numericals on this paging, we can start from here. Like, can make a table. Okay, so here first we have logical address space, physical address space, logical address, physical address. Now we have page size, we have page offset, pages means number of pages, then frames means number of frames, then we have page table entry and page table size. Okay, yeah. So you can see like I'll give you some examples. Okay, like this. Push करो भाई. बार बार आ रहे हो तुम, पता है तुमको?
मुझे मतलब मेरा लॉक हो जाता है बार बार।
हाँ, लॉक खराब हो गया है इसका।
अच्छा अच्छा।
So suppose you have given that logical space is 128 KB, this is also 128 KB, page size is 4 KB. So this is given. Now found out the logical address space, logical address, not logical address space. So this is logical address space and this is logical address. So found out the logical address and physical address. So I am giving you this example. So I have not made any question today. So this is the question for you. So if you solve this, so you can then solve any such similar example from this, from here only. Okay. So so can you find out this, like what will be this, this, and this? So with just these three information you can find out all of this. Okay. So now if I give you, this is logical address space is 256 KB, this is 1 MB, and page size is 4 KB, and page table entry is 2 byte. Then find out all of the other. What will be this. Right? I think you got the idea. So can you confirm anyone is trying? They can give their answer, like if they are giving the page physical address, they can give write in chat box that my answer of 4A or A4 is this one, something. Mm-hmm. Is this you can write is like the page offset is like it will be A6. So you don't need to type page offset. You can write that A6 is 12. Yes, you are right. A6 is 12. Oh, I think I have deleted it. This is fulfilled. Yeah. A732. Okay, number of pages is 32. Yes, fine, right. Hmm. Number of frames is equal to, yes, number of frames will always be equal to number of pages is equal to A832. A832. Okay, number of frames. Yeah, right, yes. So one thing, that page table entry, that PT is the page table entry. Okay, this page table entry is equal to the number of frames. Okay, and maybe I'm refreshing if you don't know. And page table size is equal to number of pages. Size means, we have to just calculate how many number of pages are there and what is the each page size. Number of pages into each page size, right? Okay, so this is how we will calculate. Okay, one thing is that is page table entry size. So page table entry size is equal to physical address minus page offset. How do I found this? Very easily, that I know simple thing, that we have, like in logical address, we have in logical address. Hmm, hmm, in logical address we have, give me a second. हेलो हेलो बताओ, लैब में। अरे यार मैं क्लास ले रहा हूँ थोड़ा, अभी 8 बजे तक है, तुम लोग जाओ यार। हाँ नहीं ये नहीं हो पाएगा ब्रो, अभी क्लास चल रहा है। हाँ, ओके जाओ। So we have, this is the physical address. Okay, so this is the physical address. So we know that this is the okay, yeah. Page number, page offset, frame number, frame offset, yeah, that's fine. Fine. Number of frames is equal to physical address space by page size, and also number of pages is equal to logical address space by page size, right? This is how we will try to calculate all the other details which have unpresent here. So first come to logical address space. Okay, so how will I calculate this? So I want to calculate this logical address space. How will I calculate this? So we know that logical address space, this is 128 KB. So this is byte addressable. Okay, so that's how I know that 2 to the power 17 means 128. So how I do it basically, 128 is equal to, I know that 128, so this is 128 KB. Okay, so this is 128 KB. You can see here it is KB. So I can write it as 128 byte into 1 KB, right? So like 2 to the power 7 into 2 to the power 10. Okay, that is 2 to the power 17 byte, right? So this is 17. Now what is the physical address space? So this is also same 128 KB. So that's why I write it 17 here. So what are the page offset? How do I found the page offset? So page offset depend on, so I have written it here, that page offset depend on page size. Okay, right? So now what is the page offset? How do I find it? So as page size is 4 KB, so we know that we have seen that as page size is 4 KB. Okay, so 4 KB means 4 KB equal to 2 to the power 2 into 2 to the power 10. That means 2 to the power 12. Okay, so that's why page offset is of 12. So how many number of pages are there? So number of pages, how do you find number of pages? I have written it here, logical address space by, so logical address space was 128 KB. You can see it here, logical address 128 KB by page size, which is 4 KB. That means 2 to the power 7 by 2 to the power 2, which is 2 to the power 5, right? So that's why Diksha has also found it correctly. Yeah, Diksha and Nishant, if you have done all the A rows, then you can go to B, C, D and E rows. Try to find out those. So number of pages is 2 to the power 5 and number of frames is also 2 to the power 5, because 128 is 7, 128. So what we have to do? We have to do 128 by 4 KB for number of pages, and for number of frames, what we need to do? We need to do physical address space by this one, right? So what is the page table entry? How do we find the page table entry? So page table entry is every 10 years. Page table is basically the number of frames, or we can find this out by logical address minus page address. So which is, what is the logical address? So we had logical address space as 2 to the power 17, and page offset, what was the page offset? Page offset was, so this is 17 minus 12. Page offset what was 12. You can see it here, page offset is 12, so that is 5. So page table entry is 5. And what is the page table size? Page table size is the number of pages. Number of pages we can found it from here, to the power 5 into what is the size of each page. So page table entry is